Hey everybody, welcome to this video. It's designed to give you an introduction to 8.5. Not able to be in school for a couple of days. I'll be back on Monday, and I want to make sure that you have what you need to get some things done. I'll keep this really quick. It's a short set of notes, and I'm not going to do a video for the homework problems, but I'll put up the, maybe I will. We'll see. Let's see what happens. Okay, anyway. So today we're going to talk about what's called intercept form. So we have like vertex form and standard form for a parabola. Just like with lines, we have slope-intercept form, point-slope form, standard form. There's all different ways to represent information in a parabola. Just depends on what you know. So I want to start by going over some terms that we have used interchangeably, maybe a little bit loosely together. And these terms are x-intercepts, zeros, and roots of a function. We kind of use them interchangeably, but what you should know is they each do have a particular meaning, and I don't want to focus on it too much. Just know that for now, when we talk about these things together as a class, they pretty much mean the solution to an equation or where the graph crosses the x-axis. But I will talk about this for like 30 seconds just to give you a little bit of particular information. As you know, an x-intercept is a point. It's a physical thing on the graph. And when you write an intercept, it should look like r comma 0. So your x-intercept is -2. You should write it as a coordinate -2, 0. A literal 0 is just a value of x that satisfies this equation. And therefore, you write it as x equals 2, right? The solution or the 0 of this function is x equals 2, x equals 4, while the x-intercept would be 2, 0 or 4, 0. And then the word root is just a synonym for a 0. So you may hear me say, what are the roots of the function? What are the zeros of the function, etc. And that brings into focus then what we're going to do today, which is the final form for us for a quadratic. So if you have a quadratic that has two zeros, two x-intercepts, r1 and r2, you can actually write that equation in the form listed here in yellow. That is f of x equals a. Now that a is the same a that's in vertex form. It's the same a that's in standard form. Right? It's just controlling the up or downness of the graph, the concavity, how tall it is, how skinny. So these are things you already know. And basically, this thing in yellow here is an acceptable form of a parabola. So you can leave it like that. I think in most of the problems here, I'm going to write them in standard form. So let's take a look at some examples and just get into it and see what we can do together. Okay, so, and as I put here in the notes, if you know the zeros, this is obviously going to be the fastest way to write the function. Just like if you know the vertex form is the fastest way to write the function. If you're dealing with a line and you know the slope and the y-intercept, then slope-intercept form is the easiest way to write the function. Get the picture? Okay, so let's fill this in with kind of what we know and see what we can do. So let me get my highlighter back. Here we go. Write the equation of the function having the given zeros and passing through the given point. Okay, so they gave us the zeros, which means that this intercept form is going to be the most efficient way to get this done. So let's do it. So we have, I'm going to write it out, y equals a, x minus, now what is my first zero? -3. X minus -3. My second zero is 4. So x minus 4. This is kind of my generic form of the equation. But don't forget, they also gave us the fact that x equals -5 and y equals -1. So we're going to make that substitution so I can find the value of a. Okay, so I have 1 equals a, -5 plus 3, -5 minus 4. And that should be 1 equals a, that's -2 and -9. A times 18 So a is 1 over 18. And now that I know the zeros and the a value, I can now write this equation out. Y equals 1/8 x plus 3 x minus 4. I think I'm going to expand that. It's typical to write things in standard form. So I'm just going to do this quickly. Right, 1/8 x squared minus 1/8 x minus 3/2. And we're good to go. Number 2 is a repeat. I'll do this one without as much commentary, but it's the same setup, right? So we have y equals a, x minus 2, x minus 5, containing the point 5, or 5 for y, and 0 for x. This gives us 5 equals negative 10 or positive 10? Positive 10a. Let me slow down a little bit, write this neater. This gives us 5 equals 10a. So a is 1/2. And now that a is 1/2, I could say y equals 1/2 x minus 2, x minus 5. And again, I know I did say before that it's an acceptable form of a line. I just think typically we'll tend to write these in standard form. Excuse me. I got distracted by an email. Don't know if that came up on your screen or not. Came up on mine. So we have x squared minus 7x plus 10. And if I distribute the 1/2, I get 1/2 x squared minus 7/2 x plus 5. And that's that. Okay, number 3, again, is the same problem. However, there's a kind of a trick here you can do. That is kind of a pretty cool trick. So it's like I'm giving you a more difficult problem because I want to show you this trick that involves difference of squares. So it's the same problem, okay? Y equals a x minus. Now this 0 here has like 2 components. There's a 1 minus radical 3. Then there's a 1 plus radical 3. So because that's a binomial, I'm going to do x minus the quantity of that. And I'll do x minus the other quantity of that. And now here's the thing. I'm going to distribute the negative sign. And do you notice something? You'd have to look at it for a second. You may not pick it up right away if you look at it quickly. But I'm going to use my highlighter here. And do you notice that we have something plus radical 3? And then, let me go back a second. Something plus radical 3. And then that same thing minus radical 3. And isn't that just a difference of squares? So instead of doing this crazy work with radicals, you can actually just do the following. A, and then I've got here, I'm going to use brackets, the first thing squared minus the second thing squared. Whoops, I meant to do a bracket there. And that is a x squared minus 2x plus 1 minus 3. And now I can plug in my 4 and 7, my 4 and 7 for x and y. A student asked me yesterday, couldn't I just do that in the beginning? And yes, you absolutely can. This is just a neat algebra trick that will help you get through the problem without dealing with the irrational numbers. So I'm going to put in y equals 7 and a and x equals 4. So what is that? 16, I'll write it out. 16 minus 8 minus 2. What is that? That's a 7, right? Hang on. 7. So I have a, I hope this is not a mistake. 7 equals a, 16 minus, is that 6? A times 6. So I get a equals 6 over 7. And therefore my equation is, now the nice thing about doing the algebra trick that we did was that really, like, I'm going to go back to here. This is already in standard form, isn't it? So I'm going to cheat a little bit and just say, well, y equals 6/7 of x squared minus 2x minus 2, and then I'll distribute. So that's the advantage, in my opinion, of using that algebra trick. Yeah, you can get the value of a, but at some point you have to multiply out those irrational numbers. And I'm not happy with the way I wrote that. I'm going to rewrite that. This is y equals 6/7 x squared minus 12/7 x minus 12/7. Okay, and I got 2 more examples here. There's an example here with how to do this on the calculator. This is not important for us right now. I can show you in class, or you can follow the directions here. It's not important. I actually tried it with my period 8 class. If you're watching this in period 8, you'll remember. I don't know what happened there. I've got to look into it. I'm not ready for it to do it now. And again, here, we're going to skip this one here as well because it's the same type of problem. Now, for the homework, I realized, again, with period 8, one thing we didn't talk about that is important for the homework is that I'm going to use this space down here. The vertex, I'm going to say the x value of the vertex, is always the midpoint value of the 2 zeros. Just hypothetically speaking, if I have zeros at x equals 2 and x equals 6, right? So I have a parabola, but because of symmetry in the parabola, here's, oh, darn it. Here's, oh boy. Here's 2 and here's 6. Now I have no idea what this parabola looks like. I just made up the zeros. But remember, parabolas have symmetry. So that for any y value that like these points have in common, they both have the 0 in common, then you know that they're symmetric about this vertex. All of the points are symmetric about the vertex, right? So here's the vertex. I'm making this up, right? But if you have something in intercept form, you can find the x-coordinate of the vertex by averaging the zeros, right? So you know how like with standard form, you can find the x-coordinate of the vertex by doing negative b over 2a. That's for standard form. If you have, what do you call it? If you have intercept form, y equals a x minus r1 times x minus r2, then the x-coordinate of the vertex is just r1 plus r2 over 2. And you can plug that in to get the y value of the vertex. And that's really the lesson. I feel like I'm rushing this a little bit, but hopefully a repeated watch of it will help you. I think you're going to get this fairly easily. And we'll do, what is there, 7 problems? I'm going to do the first 2 with you on the video. And I'll do the rest on paper. Okay, so number 1, write the equation of the quadratic function having zeros at x equals negative 6 and negative 2. So we have y equals a x plus 6, x plus 2, containing the point 1, 4. So I'm putting in y equals 4 and x equals 1. So we get a equals 4 equals 21a. A is 4 over 21, and therefore y equals 4 over 21, x plus 6, x plus 2, distribute. Y equals 4 over 21 x squared plus 32 over 21x plus 48 over 21. All right, and then write the equation of the quadratic function having zeros. X equals 0 and x equals 10. This will be an easy one. X minus 0 is just x, and then x minus 10, containing the point 2, 3. 2 and negative 8, right? So 3 equals negative 16a, and a is negative 3 over 16. All right. So what does that give us? Y equals negative 3 over 16. X minus 10. Y equals negative 3 over 16. X squared minus 10x. And finally, y equals negative 3 over 16 x squared minus plus 30 over 16 plus 15 over 8x when you reduce it. Standard form. I'm going to keep going. Write the equation of the quadratic with these intercepts. Y equals a x minus 5 minus root 2. X minus 5 plus root 2. Y equals a x minus 5 plus root 2. I'm distributing. X minus 5 minus root 2. This is a x minus 5 squared minus radical 2 squared. This is a x squared minus 10x plus 25 minus 2. That's 23, right? Let's write that, 23. And I could plug in, what is it? Negative 3, 1. 1 equals a. Negative 3 gives me 9 plus 30 plus 23. 9 plus 30 plus 23. 62. A equals 1 over 62. So y equals 1 over 62 x squared minus 10x plus 23. I am rushing this. I hope I'm not making math errors. Forgive me if I am, and we'll cover it up next class. I think I'm doing them okay, though, but we'll see. Okay. And number 4 would be a good discussion problem. I feel like this number 6 we'll skip. 7 is review. I write the equation. Number 4 is similar to 3. Y equals a x. I'm going to skip the first step. I'm going to go right to the distributing. X minus 3 minus radical 2. X minus 3 plus radical 2. This is a x minus 3 squared minus radical 2 squared. Y equals a x squared minus 6x plus 9 minus 2 is plus 7. Now the x-intercept is, y-intercept is 0, 39. So when x is 0, I get 39. 39 equals a times 7. A equals 7 over 39. All right, so I get y equals 7 over 39, x squared minus 6x plus 7. So that is y equals 7 over 39, x squared, minus 42 over 39. That's going to reduce 14 over 13. And then plus 49 over 39. And that is it in standard form. Number 5, find the vertex of the parabolas in 1 through 4. Remember what I said before? Vertex, x-coordinate of the vertex is halfway between the zeros. Right? So in number 1, the zeros are negative 6 and negative 2. What's halfway between negative 6 and negative 2? Negative 4. That's my h value. Oh boy. H equals negative 4. And when I plug negative 4 into my function, I can't do this mentally. You're going to get some value. K equals f of 4. You plug in the rest. I can do this one mentally. 16, 64 over 21 plus 128 over 21. I feel like those should be opposite signs. But yeah, it's -4. Oh yeah, it's -4. So this is negative. Ah, thank you. I caught that. Though what I notice is with the vertex, these numbers are always they're opposite signs, and one is double of the other. Have you noticed that? Like 64 and -128. That's a I think it's got to do with the negative b over 2a. And then what's the third component? Plus 48 over 21. So -64 plus 48 is -16 over 21. So I get -4, comma, -16 over 21 as the vertex, assuming no math errors. All right, I'm going to do the rest of this for a homework assignment for myself, but you've got what you need to do well. I will post the PDFs over the weekend, I think, or when I get back on Monday. This is enough to get through what you need to get through. We can have a discussion next class about where you need to be. Okay, thanks everybody. Talk to you soon.